Look closely at an airplane window. It is not perfectly round, but every corner is smoothly curved. That small design choice helps stop an invisible crack from growing until the cabin tears open at cruising altitude. So why are sharp corners so dangerous? At around 35-ish feet, the air outside is far too thin for passengers to breathe normally. The aircraft therefore keeps the cabin at a much higher pressure than the air outside. That pressure pushes outward on the fuselage during the entire flight. The metal body does not inflate like a party balloon, but it does flex and expand slightly. After landing, the pressure disappears and the structure relaxes again. One flight does not usually damage the aircraft. The problem is repetition. Imagine bending a paperclip a tiny amount, then bending it back. At first, nothing happens. Repeat it enough times and a small crack forms. Engineers call this metal fatigue. Now imagine cutting a window into the side of the pressurized fuselage. The opening interrupts the smooth path of the force. If the opening has a sharp corner, stress gathers around that point. Just as a plastic bag tears more easily after you make a tiny notch in its edge, a curved corner spreads the force over a wider area. It does not remove all stress, but it greatly reduces the dangerous concentration at one point. The world learned this lesson through the de Havilland Comet, the first jet airliner to enter commercial service. It was faster, quieter, and more comfortable than the propeller aircraft of its time. But in 1954, two Comet 1 aircraft broke apart in flight over the Mediterranean. Investigators recovered much of one wreck and tested another Comet fuselage inside a giant water tank. They repeatedly pressurized it to reproduce thousands of flights. Eventually, fatigue cracks caused the cabin to fail. This is where the popular story becomes too simple. People often say the Comet crashed because its passenger windows were square. Sharp-cornered windows did create serious stress concentrations, and later Comets used more rounded openings. But the failures involved the whole design of the pressurized cabin: corners around different cutouts, rivet and bolt holes, thin metal skin, manufacturing details, and an incomplete understanding of how repeated pressure cycles could create hidden cracks. In the recovered aircraft, investigators found evidence of fatigue around an opening for radio navigation equipment. In the full-scale test, failure began near the corner of an emergency escape hatch. Modern aircraft safety therefore depends on much more than rounded passenger windows. Engineers use smoother cutouts, stronger reinforcement, improved manufacturing, repeated fatigue testing, inspections, and damage-tolerant structures designed to stop a small crack from becoming a sudden disaster. So the rounded window beside your seat is not just a stylish shape. It is one visible part of a much larger safety lesson, learned from the aircraft that introduced the world to jet travel and then taught engineers how dangerous invisible fatigue could be.